Alright, this is Unit 3 Reteach. Start off with a particular type of rubber ball that's able to bounce the same height from which it is dropped. This ball is dropped 9.91 meters, but it falls slightly away from vertical, so that by the time it is bounced to its new height, it has undergone a horizontal displacement of 11 meters. So you can see what I've added here is 0.1, not 11, excuse me, but 0.11 meters. What is the ball's resultant displacement from its height to its maximum height after one bounce? So we're looking there for C. And we also need to know what is the angle of displacement. So in order to do this, it's simply going to use Pythagorean theorem to figure out C. And then to figure out the angle, we're going to use tangent. Remember, it's the second button, then the tangent. And remember, for tangent, it's always going to be opposite over adjacent. So you can see that 0.11 is the opposite, 0.91 is the adjacent. It's the one beside the angle. So when we work this out, we get 6.89 degrees. So that would be the angle. So if I was to write this out, it would look like this. It would be 0.92 meters at 6.89 degrees, so you could round it off to 7, from vertical. Okay. Number 2 says that a roller coaster moves at 35 meters horizontally, then it travels at 25 meters at an angle of 30 degrees. We're trying to find the displacement from the starting point. So now, in order to do this one, you'll notice it's not a right angle, but we can make it a right angle. We know that 25 meters is the hypotenuse. We have a 30-degree angle there. And so to find the opposite side from the angle, I can use sine. The formula for sine is sine of an angle, which would be 30, is equal to the opposite over the hypotenuse. So therefore, we can use the algebraic formula to move the 25 meters for the hypotenuse over to the other side of the formula. So it would turn out something like this: 125 sine of 30, which would give you 12.5. Remember, when you're doing this one, you want to simply put this part in the calculator. For those of you that didn't pick up on that, what I did again was sine of an angle is equal to opposite over hypotenuse. We said the hypotenuse was 25, so that was down on the bottom. The opposite is what we're trying to find. So I multiplied both sides times the hypotenuse. That canceled out the hypotenuse on this side, leaving our formula: hypotenuse, which is 25, sine, and the angle. So I do the same thing for cosine in order to find the adjacent, because cosine equals adjacent over hypotenuse. So our answer is going to be 21.7 for the other side. So now we have one side of our right triangle, the large right triangle. We have two other measurements for the long side of the right triangle, but we need to add those two together to get our total, which is going to be 56.7 meters. So now, using those two values, I can use Pythagorean theorem to figure out the long side. which in this case is going to be 58 meters. Now if we need to find this angle, we need to use the opposite over adjacent. We can use tangent. Remember, you push the second button, then tangent on this one again. So that's 12.5 over 21.7. Oh, excuse me, not 21.7. Let's see, did I make a mistake here? Yes, I did. Let's go back. So it's not 21.7, that was only the small triangle. I should have done this using 56.7. That's the total side. So instead of 30 degrees, which we would expect to get 30 degrees the other side because this angle right here is 30 degrees, we're trying to find the other angle. So this is not going to be 30 degrees. Instead, it's going to be 12.43. So I'll round that up to, just round it off to 12. 12 degrees above horizontal. Okay, next problem, number 3. Okay, our scenario here, you have a novice pilot. He sets a plane's controls, thinking the plane will fly at 250 kilometers per hour to the north. Remember, kilometers per hour, we're talking about velocity, that's a vector, so we can treat it just like any other vector. The wind is blowing at 75 kilometers per hour towards the southeast. So you see it moving towards the southeast there, at a 45-degree angle. They want to know what is the plane's resultant velocity. So I show that there in red. So I do not know, just by doing the drawing, whether or not this is a right angle or not. It looks like it could be, but because we don't know for sure, the best way to approach this is to go ahead and divide this triangle into 2 parts and to use 2 little right triangles here to determine that. So in the top right triangle, we have some information. We know that we have a side that's 75 kilometers per hour, and we have an angle that's 45 degrees. In order to find the other 2 sides, we're going to have to use our sine and cosine like we did on the last problem. So we can do this the same way we did last time. We have the 75 is going to be your hypotenuse times sine of the angle, 45. When you do that, you end up getting 53 as your answer. So that would be your opposite. We can do the same thing again with cosine to find the adjacent, and you'll find out that it is also 53. So seeing that both sides are the same, we know that we have a 45, 90 degree angle, which we would expect it to be. So now we have one side of the next triangle, but we need to find the other side. In order to do that, we can simply subtract 53 from 250. That would give us 197. Then, using Pythagoras' theorem, we can find the hypotenuse of this triangle, which is going to be 204 kilometers per hour. Finally, we need to know this angle. The angle is going to be determined using I'll just use tangent again. And I'd use tangent of 53 over 197. Again, that's opposite over adjacent. And I get an answer of 15 degrees. So my total answer is going to be 204 kilometers per hour at 15 degrees east of north. Number 4 is going to be done just the same way. You'll notice that the pilot is going to slow the engine down 1/2 the velocity. So you're working it exactly the same way. All the other parts are exactly the same. I'm not going to talk all the way through this one. I think you can probably figure it out on your own. In fact, it would be a really good one for you to practice before you actually view the next part of this video. I'd pause it, work it out on your own, and then come back and see if you got the right answer. I will go ahead and work through it real quick for you here so you can see, you can compare your answer to it, but I'm not going to talk through this one. And again, you can see there's a lot of similarities between this one and the last one. Okay, finally, we have the number 5, the hiker. In this kind of problem, we have several different vectors on it, and so you might want to consider simply adding the ones up that are like. That's what I started off doing. I identified all those that were east, those that were west, those that were south, and those that were north. Then I added those together. Then I recognized that east and west are opposites, so if I subtract the eastward ones from the westward ones, I end up with a greater direction in the direction of west by 3. So it's being displaced 3 meters toward, 3 kilometers towards the west. Same thing. I can do the same thing with south and north. Subtract those, and I get 5 meters towards the north. Now all I have to do is take those two vectors and add them together. I draw them, one attached to the other. Remember, the tip to the tail, so the arrow tip to the tail of the next one. And then I'm going to work to determine what direction the camper needs to get back to camp. So the point of origin would be where I began the vector that was going towards the west. So now I use Pythagoras' theorem to figure out that side. It's 5.8. Then I use tangent to determine the angle. So in order to determine the angle, again it would be tangent with the second button again, because we're solving for an angle. Remember, anytime you're looking for an angle, you always use the second button first. And then it's going to be opposite over adjacent, so that's simply 3 over 5 to find that angle there. I'll confirm it. Yeah, so it comes out at 31 degrees, and it's east of south. Work through these a few times. Again, it never hurts to go over a problem more than once. Once you feel confident, feel free to come in and take the test.